In this lesson, we're going to learn about average rate of change. This is the first video in a series of 4 on this topic. In this lesson, we're looking to understand what average rate of change is and how it works. Simply put, average rate of change describes the slope of a line that connects 2 points on a function. Let me show you what I mean. Suppose we have the graph of a function. We want to find the average rate of change over the interval when x goes from 1 to 3. 1 and 3 are x values, or inputs, of the function. If we look on the graph along the x-axis where x is 1 and we identify that point, and then we go over to where x is 3 and we identify that point, we found the 2 endpoints for our line segment. If we connect those 2 points with a segment, and we calculate its slope, we have now calculated the average rate of change. So how do you calculate average rate of change? Well, it's actually a fairly simple process. To calculate average rate of change, you simply do the following. The first thing you do is find the 2 points that you need. We call those points x1, y1 and x2, y2. In other words, we have the first input and output, x1 and y1, and the second input and output, x2 and y2. Then we use the average rate of change formula. Average rate of change equals y2 minus y1, the outputs, divided by x2 minus x1, the inputs. If that formula looks familiar to you, that's probably because that's the slope formula. Remember, what we're calculating is the slope of the line segment that connects those 2 points. How do we get the 2 points? Well, you can get them in several different ways. The points can come from any of the following: 2 points on a graph, by reading them from an input or an output table, or by calculating them from the function by using its equation. We'll look at each of these scenarios in the subsequent videos that follow. For now, that's everything you need to know in order to get started with average rate of change. Remember, you can learn more about function in Mr. Dory's Algebra Handbook, available at www.dorypublications.com.